If there's not, I'm going to see if this thing can open. Let me see. You know what? Let me title this one to do that. But maybe it just was having a bad day earlier. Let's give it a minute. I don't know what's going on with this thing. Oh, that's weird. All right, that is really strange. It worked this time, but earlier this morning it didn't work. I don't know, probably the internet or something. So, um, we've kind of been doing, what is this? That is weird. Okay. They gave that as free. Now, or they don't, no, they don't allow me to do that anymore. So that's what they're doing. So you just take away, that's the way you do it. You offer people free software, you get them used to it. And then what you do is you go in and say, oh, it's a new feature, so now you have to pay for it. Guess what? I'm too cheap. So that's just wrong. There's probably going to be court cases over stuff like that. So let's do a couple of these problems here. So we talked about couples, and that was in the last lecture. We've already talked about cross products. We talked about transmissibility. Here's a couple of them. It's interesting because he does some with the matrices like this. There's the moments, the cross products, and then the couples will show up probably in the next section. See where it's written on copy filling. And there's the couples. So let's just go ahead and work one of those, and we'll work it two ways. Okay, what's a good one to work? I want to find something really weird and bizarre. That one looks good. Bizarre enough. That one looks bizarre enough as well. There's a 3D one. That looks pretty good. If I could find a more complicated 3D. Okay. 79. This one has, okay, two couples act on a frame. I'm looking at this one right here. If the result is this between couples, and then does he find, compute the result is find the moment of each couple. Yeah, okay, that looks good enough. What is the D though? D is 4 feet here, and D is 4 feet as well here. So we'll just do this one, and remember that's 4 feet. So I'm going to do it the easy way, and then I'm going to do it the hard way. Neither one, so I take that back. I'm going to do it the short way, and then I'm going to do the quick way. So here, this is the first thing. That's actually 4. Okay. That's actually 4. So he gives us a coordinate system. I'm going to go ahead and do it the harder way because I think, let's see. Was that true that I could take that photomath would take the determinant of the, I think it was. I think I found an issue. So I got 4 forces. So what I'm going to do it the long way first. I'm just going to draw vectors to each of these locations. And then what I'm going to do is cross with the vectors themselves. So, in fact, I'm going to label them 1, 2, and 3, and then 4. And so what I'll do is R cross F for 1, and then I'll list it out here, I, J, and K. And actually, what I might do is I might actually make use of something inside here. There's a cross term. And I'll do that because it's going to get mad at me. But I thought if I did that, yeah, it would just come up with a help here. So it tells you you can do a cross X and 2 vectors cross X and Y. And so what I'm going to do is list all these out. And so that'll make it easier for me to do. So first of all, the vector R1 that goes from here to there, it just goes 3 foot straight up. So I just got that vector. It has no X and no component there. F is, okay, 80 times 4/5 of it go to the right. 80 times 4/5. Then 3/5 go up. 80 times 3/5 go up, and then that. So I can multiply all that out, or I'm going to use MATLAB to cross that for myself. Okay, so the second one I'm going to do R2 cross F2, and these both should have vectors on them. And they'll have I, J, and K. And so now, since that was 4, then the vector that goes to there is just going to be 7 straight up. And, oh, he's got the 80 in this 80 times 4/5 with a minus sign on it. So, the minus sign. And then, unfortunately, it looks like I did not leave enough space for myself. So I'll do that. And then I got 80 times 3/5 with a minus. So the first thing you notice is the signs are reversed for all that. But that's okay. R3 cross F3 is just going to be the same thing. I, J, K, make a little bit more space for myself. This vector goes 8 up and 2 to the right. So it goes A up and 2 to the right. Now, it's showing 30-degree kind of drop down there. So let's see, 50 times the X component, going to be sine of 30. Okay, so here, I'll do it this way. This indicates the sign because I don't want to write the whole thing out. And then it goes up with 50 cosine of 30. And doesn't have anything there. And that's the vector that goes to the right and then goes up, and it's the 50. That's a 50. So finally, R4 cross F4 is going to be a vector that looks like this. Okay, hang on. It goes, it goes up 8, out to the right 5. And, okay, what is it going to be? Actually, I'm going to just write this down and then go back and check it. Okay, is that right? Does it go back to the left, sine of 30? And I think it does. Does it go down, sine of 30? And I think it does. Now, I'm going to do something really weird before I do this. And I'm going to do this. So if you have 2 vectors, R1 cross F1, and then you add them together, but that's not an add, and add R, my hand's not there, R2 cross F2, is it the same thing as this? R1. Well, you know what? Let me prove this first. before I start supposing. The way I'm going to do this, I'm just going to use a MATLAB command called cross, and then I put in here 0, 3, 0. So there's my vector, which is the R, and I'm going to put in, oh gosh, 80 times 4 divided by 5, and 80 times 3 divided by 5, and then nothing. So let me see how this does. Uh-oh, I can't draw it down. It's okay, I'll put it near the top, and I'll put octave below it. So here's what I'm going to do. Okay, CROSS, parentheses, and then the square bracket means I'm going to enter the vector. So there's my first vector, and my second vector is going to be 80 times 4 divided by 5, then 80 times 3 divided by 5, right? And then nothing. And then, wow, it's having to think a lot. Oh, no. Let me redo that. Okay, I forgot to put the closing parentheses. So that makes sense. It's planar, and therefore it shouldn't have an x component, and it shouldn't have a y component. It only has a z component. So minus 144 equals to minus 144. Was that right, or was it 114? That was 144. So now I can do the same thing and do the second one. And being that I'm using this kind of stuff here, I'm going to try my best to be, okay, this time I'm not going out 3, I'm going out 7. So I replace that with 7. And this time the values are the same, but they're opposite signs. So let's see if I can slip in here, stick a minus sign here and here. And then the beauty is, as I go to octave, okay, wait a minute. Well, okay. Man, the computer is acting weird. So I can do an arrow up. You can roll over to here, put a minus sign, roll over to here, another minus sign, and then put a 7. 336. Now look, notice it has a minus sign right there. I think probably it does all the math, and it probably has a 0.0000, a bunch of zeros and a 1 or something out there. So anyway, it's 336. And I should have put the K here. We go 336K. Was it 336 or 366? 336. I'm just going to add these two together and say, okay, uh-oh, I think I hit a caps lock. Okay. Okay. 336 minus 144. 192. Okay, so now let's kind of look at this thing. There's two ways we can look at this, okay? If we're doing a cross product, I mean a couple, obviously the couple is, this one's going one way, and this one's a certain distance, and it's going another way. But what you really have to do is you have to find this distance, the perpendicular distance between them. Now I know that's 4. This distance is 4. So if you think about this, and actually this is a good case you can kind of look at, although the aspect ratio up there on the screen is a little different than what I'm seeing. That's really weird. So I contend that this angle is the same as that angle. So here I'll sort of color it in a little more. This angle is the same as that angle. And it makes sense because if I took this line and progressively moved it up to here, well, wait a minute. Let's think about that. So I moved it up to there progressively. Yes, this angle would collapse, and so too would that. So, yeah. So that means what is, this looks weird, but what is, here, I'll do it this way. Change color. So this is 4. So what is that distance? And then what is this distance? Okay. Actually, I don't care about what that distance is. Sorry. I don't care about that. But I know this one is 4/5 of that one. So 4/5 of 4 is a number. Then we multiply that times 80, and what number do we get out of that? I have no idea. 80 times 4/5 of 4. 256. That's not what I expected. So he's saying 256, or that's what I'm saying. But that's not what I get from that over there. So is my geometry off? Uh-huh. Did I? In the MATLAB? I did. Okay. Okay, let's fix that. The first one's 4/5, right? You caught me. You were letting me go extra so you could laugh at me. Okay, that's the plus one. Here's the minus one. Okay, 192 and 448. Okay. 192 and 448. Okay, I gotta add those two together. Okay, 448 minus 192, 257. Interesting. And over here I'm getting 256. Okay, let me multiply this back out again. Okay. It comes up exactly at 256. Am I not seeing that? Exactly at 256. That's really strange. Okay, why does this come as an extra digit there? Okay, let me go back and look at this. That's 257. Oh, now it's 256. It's supposed to be 448. So I put in 449. Okay. All right. So through stumbling through this, I got them both the both way. Now the next one, you could do it I don't know. See, the thing is which one's easier for whom? That's the thing. I don't really know. Some people may find it to be easier one way, and some people may find it to be easier the other way. So let's go ahead and do this. That angle right there is going to be your 30 degrees. This distance is 3. So unfortunately, 3 times cosine of 30 is equal to 3 times cosine degrees of 30, 2.5981. 2.5981. That's the distance. That's the perpendicular distance between them. Now, if I multiply it times 50, I get, okay, I'm just going to do that and then say 50 times that. 129.9. 129.9. So that's kind of what I see right there. But what I'm going to do is I'm going to go ahead and do this if I don't goof up. Don't let me goof up again. So here we go. I'm going to go in and do it in here. So I'll do a cross. Let me write it out so I can make sure. 280. And then I'm crossing that with the vector that is 50 sine and a D for degrees. And then comma. No, I got dust on the screen. Hang on. That's not dust. That's some sort of sticky stuff. 50 cosine degrees of 30. And then nothing. And what does that equal to? Let's see. Go back to the cross so I find the cross. Okay, I'll just copy those numbers out. 2 and 8. 2 and 8. That'd be funny to see what that does. That's not going to do. It won't. It'll go nuts at me for that. Okay, so that's 50 times sine degree of 30, and then 50 times cosine degree of 30, and then nothing. Oh, I already have a nothing there. Okay, 1339, 113 point with a minus sign in front of it. 39, 746. I don't need that many digits, but so now I'll take the same thing, copy, put it right here, and hey, wait a minute. Okay, yeah, 2, and then a 5, and then a minus, and then a minus. See if I can do this correct. Did I do that last one right? So first of all, got to put in a minus 5. Not a minus, but I give a minus and a 5. And you see, minus 16.50635. Now if I add these two together, and what I'm going to do is I'm just going to try to see if I can copy them here. I'll just say this. Oh, wait a minute. I could do something. Well, now I'll just copy and say this. And then I'll leave the minus sign on there so I don't have to put a plus. And then I get 129.9. And it's a minus. And that's what I got here. However, the sign. Why do I have the sign this way? Okay, so if you look at this, here's your X and Y. This is always a positive because if you put your fingers, your pointer finger at X, roll it towards Y, then your thumb points up. So this is a plus sign here. If you look at this moment, it's going that way, or it's plus. You look at this one, it's going the other way, or it's minus. So here you got a number, but your sign convention, you need to basically say 129 like that. Which is a minus, and over here you get a plus. Now the thing is, you got to be careful if you're doing it the other way where you're finding the distance that you catch up with the sign, because otherwise you may make the mistake of adding this number to that number when in fact you need to subtract them. And so technically what the answer is like a competition bracket here. 256 minus 129.9, and that's the number that you finally get. Now, I just want to try something. And I don't think it's going to work. No, as a matter of fact, it can't work because here, if you do R cross F, or let's say, well, we'll do that, plus R2 cross F2, is that equal to R1 plus R2 cross F1 plus F2? And I don't think it is, because you do the cross products, you get this R1 cross F1 plus this one, R2 cross F1, should not exist. And so this is not equal to. And so you can't add the two vectors together and then cross them. So you got to do them individually. And so, that doesn't get you anywhere. You just got to do them individually, each one, if you decide to do it this way. If you decide you would prefer, you can find the perpendicular distance between these two. Sometimes that's easy, sometimes that's not. Now, one of the questions he may have asked, and maybe this is just me not knowing what he's asked, is, let's see, resulting couple moment. Yeah, compute the result by resolving the force into the x and y components. Find the sum the moments. Okay, that's one way to do it. Two couples acting on the frame, determine the resulting couple moment. Compute the result by resolving the force and find the moment. The sum. Okay, so they're asking you to do it different ways. Determine the distance d between the 80-pound couples. Oh, okay. So he's doing, okay. So he's leading you through the problem. So that's the only reason he's doing that. Okay. So that's essentially it. That's all you're doing with these. Let's look at this one for a second, and let's do it the short and cheap way. 190, let's see, both of these. Okay, so he says, let's do this one. It says it's supposed to be 125. If I take that and bring it over here and drop it in here and just add another page and work it off that page. So he's saying that's 125 and that's 125. So this is a 3D one in a way, but it'll work out okay. So I'll call this one 1 and this one 2. I'll do it the long way first. So I should have put R1 cross F1, and that would be I, J, and K. And the I is running out this way. So I ran out, you know what, instead of using those, I'm going to use 0.6. So I ran out 0.6, 0.8. I run all the way out to here, and then I run across here, 0.8. And then I run out here, 0.15. And then I don't run out that way at all. And R2 cross F2. Oh, I forgot to put in the force. Okay, this force goes in the positive Z 125. I, J, and K. And R runs out 0.6, and then it runs backwards 150. And then it runs 125 the other way. So let's do those particular cross products. Wrong window. And shouldn't be too bad. If I go back to the point where I see a cross, that's interesting because go ahead and get rid of all that. 0, 0, 125, and then 0.8, 0.15. This time, I get 2 in the X. I mean, they're both populated. There's no Z. Let's see, 18.75, 18.75I minus 100J. Now, think about that for a minute. And how should I get rid of some of this? So, in fact, if I drew a line all the way back to here, so this line comes right here, this thing will create a twist here, and it's going to create a little twist there. So, in fact, if you think about it, this twist is going to be, okay, you take your hand, you roll it that way. This twist has a vector that goes this way, and this twist has a vector that goes that way. So it's minus in the y and plus in the x. So it's minus in the y and it's plus in the x. So how did I know the signs? Because if you look at it, you take your fingers of your right hand, you roll them that way, and you point your 4 fingers rolling that way. And which way does your thumb point? Your thumb points this way. You take your fingers and roll it around that axis, and which way does your thumb point? Your thumb points this way of your right hand. So, in fact, those numbers came out to be reasonably comforting. That now let's take this one and try to see what we get here. So here's your R. So it is actually twisting this way about this axis, and it's twisting that way about that axis. Okay, so take my hand, I run it there, that's a positive. Take my fingers and run it there. So I should get 2 positives out of this one. Let's see if I do. So, unfortunately, it's kind of in the way. So now, 125 does a minus, and I run back, and I run that way, and there you go. 18.75 and 100. 18.75I plus 100J. And, of course, you add both these together, and you get, well, here, I'll just 18.75, 18.75, times 2. I may have. Oh, in the last? Oh, I don't think I did. Thank you. 18.75. Okay, hang on. So actually, it changed that. Okay, let's say it didn't. Let's say I didn't catch that. So this would be supposed to be minus 25. So if I didn't catch that, the question would be, okay, these two go together. They'll obviously create a couple this way, and they'll obviously create one this way. So I should have caught that through the, even if I didn't catch it numerically. Okay, so what do I mean by that? In other words, if I look at this, these 2 wrenches are going to go together to create a twist about this axis. So I'm going to get a plus X number, or plus some number times I. Now, do they create a couple this way. Yeah, they do. It's taking a twist about, okay, roll it that way, and it's taking a twist about that way. And that's the minus some number times j. Did I get that? Yeah, I got a plus some number and a minus some number j. So I should have caught that by visually trying to look at what happened there. And so, yeah, I've slipped up on the MATLAB entry several times. So you can do these either way. And, oh, I didn't do it the other way. Okay, do I have time? I got kind of time. But the problem with the other way, it'll tell me the couple, but it's not going to tell me the dimensions or the value in each thing. So if I'm looking for the distance between here and here, what is that? Well, that's twice the distance between here and here. And it should cross, so that should be a triangle that is 0.1, 0.15. So what I'm doing is I'm taking this triangle and I'm looking down on it, and I don't know what that is. So that's 0.15 squared plus 0.1 squared, and square root of that, and then multiply that times 2. I'm going to cheat. I'm going to do this using that. Let's see if it can actually get that. It should be able to. It should be 0.360555. Now, that is this dimension, so I've got to multiply that times 2 times 0.360555 times the 125. Well, my handwriting looks weird there, so let's see if it will pick that up as a 2 or a 7. Well, it did pick it up as a 2. Then I get 90.13875. So the question is that, is that the same thing as 37 squared plus, and I left some digits off, 25 squared. I do not know. I feel an uneasiness here. 44.65. No, they are not the same. So I did do that. Yeah, that's a good question. I don't know why I did that. So that's 3 mistakes today. You know what? And I had caffeine today. Okay, now let's see. Oh, it's 45.069. That's close enough given the fact that I threw away all those digits. So I don't know which one you want to do. In one way, this is kind of beneficial if you get it in vectors, because then if you had it in a vector, you would know, like, okay, if I'm going to unscrew here or screw it back in here, you know, what am I going to do? I don't know. And then you would dot it with the value coming out here, and that would tell you what's effectively being useful there. I don't know which one's better. I guess it depends on what he's asking. So, okay. Look at that. Let's see. See, I think if I sit down and sit at the computer, I fall asleep. I went to the doctor the other day, and he's a sleep medicine person.